Hello and welcome to this presentation on potential difference. My name is Mr. McQuire and this is lesson 4 in the topic of electromagnetism. So as you can see, so far in this learning journey we've looked at static electricity, then currents, then series circuits, and finally today we are looking at potential difference. Some of our keywords from previous presentations. On the left hand side of the page we have the keywords current, electric charge, potential difference and insulator. And on the right hand side mixed up we have the keyword definitions. I'd like to spend a minute and a half seeing if you can work out which keyword goes with which definition. Okay, let's have a look at those and see if we can remember them for future use. First of all, current is the rate of flow of electrical charge and it's measured using an ammeter. The electrical charge, it can be positive or negative, and we've got this word here, electrons, which can carry a negative charge, and negative charges can be transferred. Potential difference is the difference in charge between 2 points. That's why it is a difference. It causes charge to flow and it's measured using a voltmeter. An object that does not allow charge to flow through it easily, for example plastic, is an insulator. So let's put those in the right order so that we can see those clearly. Now it's really important that we learn those and get those definitions under our belt so we can recognize them in the future. If you need to pause the presentation and just reread them, then please do that now. So as we start our learning journey today, let's try and find somewhere as free from distractions as possible. And you will need to find yourself a pen, paper and a ruler for today. So I'll give you a minute just to get yourself together. So our learning outcomes for today for our challenge is to be able to measure the potential difference in a series circuit. and for the aspirers to be able to explain the effect of altering potential difference, or PD. Our prior knowledge from previous lessons should tell us about these particular diagrams. For each of them, I'd like you to copy them down into your notes under the title of potential difference, which I have underlined in the top of the learning outcomes. It's in bold as well. And then I'd like you to write down what would happen to the bulbs, and I'd like you to explain why. Now, I've given you a minute and a half to put some decent detail into those and draw some nice diagrams as well. So if you can spend that time properly, that would give us a really good outcome for that. So use your prior knowledge from previous lessons to explain what would happen in each of those diagrams and why. So you should have had a go at A. So you copied the diagram out and explained what will happen at the bulbs and why. Let's have a go at diagram B. Do the same now, please. Before we look at the answers, let's just check that we've got those cells the right way around. It's really important that we confirm those. So we've got plus, minus, minus, plus, plus, minus, plus, minus, and then we've got a minus, plus. So just be careful that you've drawn those properly. Okay, so circuit A has one of the cells the wrong way around, and this means the bulbs will not work at all as the electrical charge will not flow. So we've got basically one cancelling the other one out, is how I would put it. Let's look at diagram B. we've got two cells in there that are pushing in one direction, but only one going the other way. So therefore, the two cells that are pushing in the right direction will effectively provide a larger push than the one pushing the other way. So the bulbs will light up, but they will be dim. Okay, you can see that in the explanation that's there. Again, this is just looking at prior learning that we've already covered in previous lessons. Let's move on now. So potential difference, the difference in charge between 2 points, and that causes charge to flow, and that is measured by a voltmeter. We have the symbol that you can see on the right hand side there. And our voltmeters are placed in parallel to the component being measured. And what that means is that we are applying it. So here is one line in the circuit through the bulb, and parallel to that line we have the voltmeter, which is put around the component. So if you want to measure the difference in something, and this is how I like to think about this, then you need to know what it was before, and then you need to know what it is after. You need to take those two things away, and that will give you the difference, and it's the difference that's measured by a potential difference meter. Now what I would like you to do is to spend a minute and a half now drawing the diagram. You've already got the title at the top of the page, but we need the circuit symbol and we need the two little paragraphs that are there as well. Let's just review what we've got. We've now got a definition, a diagram of how to connect a voltmeter properly, and you'll see that later in this presentation. You've got a symbol and you've got a description in words of what's happening in the circuit diagram in terms of it being placed in parallel to the components that are being measured. Let's look at the application of our learning then from the previous work that we've just done. We have a question in front of you, and the only thing that I would like you to notice before I let you loose on this question is to tell you first of all that I'd like you to copy the circuit diagram before you answer the question, but then I want to mention the word each that is in that question. Okay, so I'm going to give you a minute and a half to answer that question now. Let's have a look then at your answer. First of all, I want to go to the question, which I didn't read out for you deliberately this time. Add a voltmeter to measure the potential difference across each bulb. So your answer must have a solution to that issue for each of the bulbs. Let's look at that. So that's roughly what your answer should look like. We're measuring the energy in the electrons before and after each of the bulbs, and not across both bulbs, which would only have required 1 voltmeter. Next in our lesson, we're going to introduce some practical work, and we are going to look at the effects of increasing the potential difference. So I'd like you to put that title that we have there. This is a very busy slide, and I want to introduce the bits very gently so that we don't overdo what's about to appear. But let's start introducing things now. First of all, on the left hand side of the slide, and I shall show you over here, we have the methodology that I will be following in the clip that follows this. That's repeated over here, which was part of a worksheet we'd use in a lesson. Setting up the circuits as shown in each of the diagram is referring to these circuit diagrams that we have over here. You can see that this has V1 and V2, and in that case then we are looking here at this results table, which only has V1 and V2 in it. This is V1, 2 and 3, which is circuit 2, and then we have this, which is circuit 3 down here. Now, once you put the title down, what I would like you to do is to put the method down, quite a chunk of work, and then to put down the circuit diagram followed by the results table, the circuit diagram followed by the results table, and the same again here. Now, I don't think for a second that anybody could do that amount of work in about a minute and a half, but I do think that you could pause the presentation to allow yourself sufficient time to get it finished, and that minute and a half is something that is just here to give us a time frame. So please pause the presentation as you need to after that minute and a half has run. So this is circuit number 1, and in this circuit we have V1 and V2, and we just have a single bulb that we're measuring the potential difference around. So here is our constructed circuit. You can see that V1 we are recording 6.4 volts, and V2 we are recording 6.03. And you can see that the brightness of the bulb is very bright. Let's just record those. V1 is 6.4 and V2 is flickering around 6, so I'm going to put a straight 6 down there. Okay, so this is circuit number 2, we have in this one 2 bulbs in series, and we have 3 voltmeters, V1, V2 and V3. So here is the circuit constructed. You can see that V1 is 6.67, V2 is 2.81 volts, and V3 is 2.18 volts. So let's put those down. 6.67, 2.80 and 2.18. Okay, that's circuit number 2. So circuit number 3, we now have the same number of cells of batteries too, which is V1 that we'll be measuring, but then we've got 3 bulbs in series, V2, V3 and V4. So let's have a look at the circuit, which is now a large jumble of wires. You can see why circuit diagrams are very helpful to help us with this. V1 is 6.76. Got some variation in the bulbs in this now. V2 is 1.33. V3 is 1.76. And V4 is 1.14. So let's go back to our results tables now. Let's see if we can record that information. V1 is 6.75, V2 is a 1.33, V4 is a 1.77, and V4 is a 1.18. Let's look at the brightness of the bulbs for our observations for a second. You can see that the voltages vary slightly, and you can see that there is indeed a slight variation in the brightness of the bulbs between them, but effectively the energy is being shared. So having watched the clips, you should have observations that look similar to these. So let's go through them together. First of all, in the first experiment, the bulb was very bright, and I've written that in there. And you can see that the energy from the battery is 6.4 volts, and the vast majority of that is now being recorded as being used potential difference at the bulb V2. And then in the second experiment with the same number of batteries, you can see that the voltage is divided between the 2 bulbs. The bulbs are very different from each other, although technically they should be the same. So we end up with these differences between the potential difference being measured at both bulbs with a voltmeter, as you've just seen. But the one thing that we do know is that the energy is significantly less, as you can see, so they are much less bright than experiment 1. And then with experiment 3, of course, we have 3 bulbs in series. We have a very similar amount of energy going into the experiment as we had in experiment 2, but the energy again is being shared between the 3 bulbs this time instead of 2. So therefore the bulbs are significantly dimmer than either experiment 1, which is very bright, or 2, which is less bright than experiment 1. So if you need to complete your results, then you can either go back to the clips and watch them again, or alternatively pause this now. Excellent, we've done much work in today's lesson, and now is an opportunity for us to show our learning. You need to copy out parts of the question only where it needs you to do that. For example, part A, where you need to add a potential difference voltmeter to the circuit diagram. Other parts where you're just filling in the gap, you can do that separately. You've got a minute and a half on this, the first of 2 plenary questions that we're going to look at today. Okay, let's look at your answers to those diagrams. I'm just going to describe what your answers should look like. First of all, add a voltmeter to the circuit diagram so you can read the potential difference of the bulb. So the bulb is this, so you've identified that circuit symbol as the correct one. So we have here a connection on this side and a connection on this side, and then a V in a circle going around there. You could have put it on the inside of the bulb. I guess it will make no difference to your marks. Now let's try the next question. The battery above has a potential difference of 9 volts. The motor has a potential difference of 8 volts. What is the potential difference of the bulb? So in the circuit then we have 9 volts, 8 of them have gone, so therefore answer in here would be 1 volt. There's no suggestion that you would need to do any maths, but obviously that would be 9 minus 8 equals 1 volt that you could have written in there. If the motor is removed from the circuit and the wires connected back together, what will happen to the bulb? So fairly obviously, if there's 9 volts and the motor was using 8 of them, the answer would be that we would be looking at a large increase in the brightness of the bulb, and it's just a description that we need. So if you need to just pause for a moment just to complete your answers properly, please do that now. We're going to move on to our last plenary question. So this question looks more complicated. It's got various parts to it, and again I'd like you to read it closely. I don't want to give you help at this point. I would like you to copy out parts where you need to. Otherwise just put the A part 1, 2 and 3 and write the answers down. So if you need more time, just pause it. You could have another minute very easily to answer that question, especially as you're drawing parts out as needed. So first of all, part A. This is a stretch and challenge question, so there's a little more work going on in here and a bit more thought. The lamps in the circuit drawn below are all identical. Each of the cells has a potential difference of 1.5 volts. So there's one cell, there's 2 cells here, and there are 3 cells here. What is the potential difference across the 3 cells that are joined in series? So they're referring to this particular diagram here. So 1.5 added to 1.5 is 3. 3 added to 1.5 is 4.5 volts. So your answer that should be written in here is 4.5 volts, just 1.5 times 3. Just check that on your answers, make sure you understand where that has come from. I hope you noticed the diagram had that particular part in it. Let's try part 2. What will be the reading on the voltmeter labelled V2? So we have got 1.5 added to 1.5 going into the circuit here, which is 3 volts. There's only one bulb, so therefore the answer that we have here should be 3 volts, because of that particular bulb is receiving all of the energy from those 2 cells that are here. So that's 2 down. Let's try the third one. Which voltmeter, V1, V2 or V3, will give the highest reading, and draw a ring around your answer. Now that's interesting, isn't it? It's a more complicated question. First of all, we have 1.5 volts here. We have 3 volts here, and that's going through one cell. So that we're going to rule this one out, the first diagram on the left, very quickly, because this one is higher than that. But let's just look at this one for a second. Here we have, we said earlier, 4.5 volts, but it's being shared between 2 bulbs, which would give us 2.25. So if we've got 2.25, that's lower than the 3, so therefore the answer that I am going to put in here is to circle V2, because V2 was 3 volts, and this one here will be 2.25, adding up to 4.5 volts that's coming from the cell. So slightly more complicated question, hopefully nothing that you have found too difficult. So let's look at our learning outcomes from today. For the challenge, we have looked at measuring the potential difference in series circuits, and you've done that through the film clips and recording your results. And then for our Aspire, to be able to explain the effect of alternating potential difference, and we've just checked that through the plenaries. My name is Mr. McGuire. Thank you for staying with this presentation today. Goodbye.